In question number 16, age and productivity data correction analysis. Using age and productive data from question number 4, normalize both attributes using Z-score normalization and compute person's correlation and coefficient and covariance comment on whether the relationship is positive or negative. Question reference from the fourth question of data, which is not provided in the image. I'll demonstrate with the typical faculty's age in product data. Assume the data is MCA faculties as you see in the PDF. Have a thin columns, faculty ID, age, and their productivity according to their faculty ID. And normalize both the attribute using Z-score normalization by this formula. So the mean of the mu equals to, and with this 43.833 with the age minus mu and the 1076.14 age minus mu square. And in the standard deviation of age, approximately 14.67 after the table. Finding Z score for the age and Z score for the typically it given by them. And for the productivity, the sigma productivity of standard deviation approximately 0.639 and Z score productivity for according to this table for have a productivity chart and the column of Z square with defining the productivity of each number of them. Normalized data metrics. In this table, there are three columns faculties, Z edge, and Z productivity according to the question. B. Compute person's correction and coefficient and covariance. Person correlation coefficient formula using R Zx into Zy upon n minus 1 and for equivalent R equals to x minus mu x y minus mu y upon n minus 1 standard deviation of x and standard deviation of y calculating using normalized score faculties and they into their age z age into productivity. So the r equals to the approximate value of Pear- Pearson's correlation and coefficient equals to plus 0.212 and covariance formula equals to covariance of x comma y equals to x minus mu x y minus mu y upon n minus 1. In this table, there are four columns by the faculties and the sum of their product. The sum of their product equals to plus 12.362 upon 5 equals to the actual covariance approximate is plus 2.472. Key finding factors correlation coefficients are equals to plus 0.212 positive relation as age increases productivity slightly trend to increase. Weak correction value is between 0 and zero point 0.5 indicating weak and association. Interpretation age explain only r square equals to 0.2122 equals to 4.5 percentage of variance in the productivity. In productivity variance due to the other factors 95.5% resource collaborate etc. Covariance plus 2.472 positive value confirm positive co-momentum and scale depends value depends on unit relationship with coherence equals to 0.212. Practical interpretation of this is mid-career peak and faculties aged 48 shows higher productivity 3.2 papers upon year. Early career younger faculties aged 20 have lower productivity, maybe establish themselves. And later career older faculties between the 60 and 60 3 shows the decline productivity of 1.8 paper per year. And implied pattern, non-linear relationship, inward U-shape, but linear covariance only capture average trends. For statistical significant consideration, with only n equals to 6 observation, r equals to 0.212 is not statistically significant. Critical values of alpha equals to 0.05 with the df of 4 is critical. Approximate value of this is 0.811. Cannot confidently include population relationship exist. Conclusion: this positive correction suggests a weak positive relationship between age and productivity. However, the relationship is weak and the actual pattern may be non-linear, productive peak mid-career than decline. Other factors are much stronger determinant of research productivity. Let's move on to the next question. 17th question. Student project evolution data scores and partitioning. Suppose student project evolution scores it are the data given in this partition into been using A equal frequency partitioning and B is equal with partitioning and C is clustering. Solve this question. A equal frequency partitioning. Divide data into bins with the approximate equal number of record per bin. What's the target of this? Let's participate into a 4 bins n upon 3 equals to 12 upon 3 have a 4 records in bin. The first step is sorted data. To sort data, the data is already sorted. You have given seen in this PDF. And the step 2 is determine bin size. Determine bin size before. The number of bins are 4. And step third is to design a table that records the value of each columns, bin records and range and bin width. Characterize equal frequency and third record each and unequal bin width with better representation data distribution captures and cluster. Be equal with partition. You want to in this in this method we have seen the divide range into the bins of equal width. First, calculate range. If we have to calculate the range, maximum minus minimum, that equals to the range we have find 210. Step 2. Determining number of bins using Strag and rules. K equals to log to n equals to put the value of 12 in this. So the answer is 4 bins also, or specify a number directly using 4 bins for a comparison. The third step says calculating bin width. So the formula of the calculating bin width is range upon k. So the range we have 210 upon 4. So the right answer of this is 52.5. And the fourth step defines the bin and assign the records. In this table, there are some columns that define the bin and range or record data to count all the values of there. In characterization, unequal frequency is 8, 2, 0, 2 records. And equal bins width is 52.5 each. An empty bin is 3 and fails to capture the clustering. Let's move on to the last method, clustering. Group records based on the statistical distance of similarities. Method 1. K-mean clustering. K equals to 4. Process rand- randomly initialize 4 centroids. Second one is assignment point to the nearest centroid. Third is recalculate centroid. And fourth, repeat until convergence. With the help of the simplified result after the convergence in this table, making the cluster values and put the records on it and centroids for their interpretation. In this, 4 columns are ready to. Okay. In this table, we have to find the characteristic of this meaning grouping based on the proximity. Second one is capturing natural clustering in data. Equal is equalish and frequency of this and interpretable, poor and good or excellent. Advantage of clustering is discover natural data group, can identify outliers and support domain interpretation and flexible bin boundaries. Comparison of method. In this aspect, equal frequency, equal width and clustering. With the given data, we have applied all the things on it. Let's move on to the question number 18, attribute selection technique by the flowchart. Use the flowchart to summarize the attribute selection technique for the feedback. First, A forward selection, B backward elimination, and hybrid method. First one, applying first one with the solution of this. Attribute selection technique for the feedback may start. Start to three attributes with the near zero variance. Yes or no. If it is yes, remove the features, and it is no, evaluate the initial model. The initial model. You see in this table, after going to the forward selection or the backward selection or a method A and method B. Start with no featuring empty set if this function is yes. For each remains feature, add one and one evolution model. For each remaining feature and remove one and evolution model. Start with all feature. Select features with the high improvement in performance and select feature with the lowest performance loss. Add to select the sets or remove from sets selected set. Improved the threshold and loss threshold. If this is yes, repeat the loops. If it is no, continue the loop. And the loss threshold, if have the yes, it repeats, and if have this have no, it also have repeat. Otherwise, stop the process. After this finalize selected feature subset, generate final prediction model evolution test set performs satisfactory. If it is say yes, adopt the model, and if it is say no, try the hybrid method again and again. And for the after this process, method C is hybrid. Combine forward and backward. Start with the empty sets and add highest value featuring. Attempt to remove lowest value feature and repeat 2 to 3 until stable. Compare result of A, B and C. Select the best performing subset in the table. Final model and end the program. Detail pseudocode for each method. Method A forwarding selection, selection featuring, remain feature and all available feature. While stopping criteria not met. For the each feature in remain feature, test features and select feature plus featuring and applying some if condition and else condition to break and run the program. Then selection method B backward elimination that select feature all available features while stopping criteria not to meet. Worst feature equals to null and worst loss equals to 0. Applying in the code after using for loops, if and else loop, and returning the selecting feature. Method C is hybrid, stepwise regression. Select the feature first to while stopping criteria not met. Forward stepping best feature equals to forward and select step presses. If best feature, select the feature add and put it in best feature by the backward step and using the if else in the code. A specific application for feedbacking analysis and initial feedbacking, teaching clarity course, organization, content revealed and feedback quality, interact level and assessment fairness and resource adaptiveness and overall satisfaction, etc. Forward selection. Test each feature individually for the predicting overall satisfaction. Select teaching clarity square equals to 0.68. 8 course organization R equals to improve to 0.7% after the initialization everything like assignment fairness and interaction level, resource adequacy, to final selecting feature, teaching clarity, course organization, and quality assessment fairness, interaction level. So the result of this is 5 featuring explain 74% of variance in overall satisfaction by the summary table, technique, technique forward, backward, and hybrid. Best for, let's talk about the forward. It is best for building the model. Pros is simple and fast, and cons may miss interconnection and greedy. Backward is reducing overfitting, best for, and pros is consider all features, but the cons are computationally expensive. And hybrid model best for balanced approach on pros in combine and advantage, and they are more complex. So in this video we have seen the all the part of C. Thank you.